Alright, we'll finish trigonometric equations today. And to start with, I actually want to do something that maybe I should have done last time. I was reflecting before I did this video. I was thinking about the general form here, and I was thinking that maybe it wasn't too clear with the unit circle how to get the general form. So I thought we would use another strategy for trying to figure out the general form. So first of all, let's kind of review here. If I wanted to solve this equation, for what values of x does sine x equal 1/2? Okay, so the way I kind of do this is I think of my angry Serbians take creatine. Sine's positive here, so where could it be? Which quadrants could it be in? Well, they're all positive here, and sine's positive in this one. So those are the two possible quadrants. Now, when does sine, for which value, which angle, does the sine of that angle equal 1/2? And hopefully this is one of the things you have to memorize. You remember that if it's 30 degrees, it's going to be a sine value of 1/2. And of course, if you had a reference angle of 30 degrees here, you'd also have a sine value of 1/2. However, we're not interested in degrees here, we're interested in radians. So what's 30 degrees in radians? It is pi over 6. So this is one of your answers, x equals pi over 6. And the other answer is x equals, we need to know how much is this angle from here all the way to here. Well, remember how we do that? We take the whole 180 degrees, or pi, and we subtract the reference angle, which is pi over 6. And if we do that, as it common denominators, we'll get 6 pi over 6 minus pi over 6 equals 5 pi over 6. So those are your two answers there. You have one answer of pi over 6, and you got another answer of 5 pi over 6. That's within, this is our answer in this interval between 0 less than or equal to x, which is less than to 2 pi. Now, last time when we did this, to get the general form, I kind of talked about, well, if this angle, 30 degrees or pi over 6, gives you a sine value of 1/2, the next time you get that value is if you went all the way around the unit circle again. So that's why the general form would be x equals pi over 6 plus 2 pi, which is once around the circle, and you can go around as many times as you want, so we put n there to show it could be 0 times, 1 times, 2 times, negative 3 times, whatever. And similarly with this one, it would be 5 pi over 6, which takes you to here, and then you could keep going around again and again and again, so plus 2 pi over n. Now I want to take a second to show you another way that you can think of this general form that might help. So take a look at this equation here, this sine x equals 1/2, and we're going to use a graphing calculator to solve this. So the graphing calculator I'm going to use is it's called Desmos, is the desmos.com. I just found it recently and I really like it. This is I think a new and updated graphing calculator online, and it's wonderful. I would totally recommend it if you don't have one at home. So again, the thing we're going to graph is sine x equals 1/2. The way we do this, remember, is we're going to graph two things. We're going to graph y equals sine x for the left hand side and y equals 1/2, and then we'll see where those two graphs cross each other. The other way you could do it if you wanted to is you could put y equals sine x. You get everything to one side, so you move the 1/2 over, subtract, so you'd have sine x minus 1/2. You could also graph this, y equals sine x minus 1/2, and you'd be looking for where it crosses the x-intercept. You'd be looking for the zeros. I prefer doing it this way, entering in two short equations. So that's what I'm going to do. Y equals sine x, should have an x there, and y equals 1/2. So let's go to Desmos and do that. Y equals sine x, so y equals sine x, and there it is. It's just the way we remember it to look. Remember, this is the mother function sine graph. It goes through the origin, goes up as high as 1, and it goes down as low as -1. This thing's awesome. I love this. And the other thing we're going to put in there is y equals 1/2. And there's our 1/2 line, right? It's halfway up to 1. So what we're interested in is where are solutions? Well, the solutions are where they cross. So one solution is at pi over 6. And I believe if you look, that's an answer we have. The next one's at 5 pi over 6. Do we have those answers? Pi over 6, 5 pi over 6. Aren't these graphing calculators wonderful? You're probably wondering, why didn't we just use this all year? Because I don't think you learn as much when you do. But it is useful. Now, what I'm interested in is the next answers out here. So what's the difference from, like, this is the next spot where it crosses, where there's an intersection. So if you look, do you see the difference between this point right here and this point right here? It's one period exactly, right? It's moving up and crossing the line. The next time it's moving up, no, this is moving down. It's moving up and crossing the line. That's one period right there. So what's the period of this graph right here? Well, you could look at it here. An easier way to look at it is where we usually look at it. Look at it from here to there. That's the period right there. Oh, the period's from 0 to 2 pi. The period is 2 pi. So this is why the next time you'd expect these two things to cross is one period later. 2 pi later from this one, it should cross again. 2 pi later from this one, it should cross again, and it does. Another 2 pi and it'll cross, right? If you go from this point and go 2 pi in this direction, you end up here. It crosses again. If you go another 2 pi, you end up here. It crosses again. If I go even smaller and go another 2 pi, it crosses. 2 pi. Same with going this way. If we start at this one, we go 2 pi in this direction, it crosses. It intersects. It intersects. You get solutions in all those locations. And this is why we have that general form which says pi over 6 plus 2 pi n. So I guess an important thing to remember when you're doing this general form is think to yourself, what's the period? And for this equation over here, for the sine graphs, remember for sine and cosine, you can get period by going 2 pi divided by the absolute value of b. Now the b value is right in front of the x there. So the b value is 1. In other words, the period is just 2 pi, and that's why it's going to be plus 2 pi n and plus 2 pi n. Okay, let's look at the next one, which is very similar. It's tan x this time, and you'll see there's just one slight difference. So again, I have a positive tan. Where's tan positive? It is positive in the first quadrant and the third quadrant. When does tan x equal root 3? Well, if you think about it, use your memory devices, whatever way works for you, you'll find that it's 60 degrees here. So of course it'll also be a reference angle of 60 degrees here. But we're not interested in degrees, so 60 degrees is pi over 3 radians. And to get this one, you take pi, the 180 degrees, pi, and you add the reference angle, which is pi over 3. If you do that, make it common denominators, 3 pi over 3 plus pi over 3, you get 4 pi over 3. So there's our answers, pi over 3 and 4 pi over 3. Now, the way I did it last class, last video, whatever, for the general form, I said, hey look, if you go from here and you go half a circle, you'd end up here, and another half a circle will end up here, another half a circle will end up here. So really, all you have to do for the general form is put pi over 3 and add half a circle, which is pi, n, because always n, for half a circle or 2 half circles or 3 half circles, and that covers it. If that's not so clear, two other ways you could think of it. Well, let's start with a graphing calculator again. So we're going to graph tan x equals root 3. Okay, there's all the places where they cross each other. Now remember, we're only interested in where they cross each other between 0 and 2 pi. Our answer is at pi over 3 and 4 pi over 3. Is that what we got? Yes, pi over 3, 4 pi over 3. We know we have it right. Now, if you look though, what's the period of this graph? The period is, if you look from here to here, it looks exactly the same. But the easiest place to look is from here to here. The period is only pi. So you see this thing crosses or intersects again every pi. Pi, it crosses. Another pi cross, it crosses. Another pi cross, it crosses. If you go negative pi, it crosses, crosses, crosses. And this shouldn't be a surprise to us if you recall that the period of a tan graph, for a tan graph, remember that period equals pi divided by the absolute value of b. Just pi, not 2 pi. So the b value again, right in there, is just 1. So our period is pi. So that's why it's not surprising to us that we're only adding pi n this time, not 2 pi n. So I think when you do the general form like this, it might be a wise move, and I should stress this last time, to recall what the period is. That'll help you figuring out what the general form is. Okay, so here's the new work today. How's this different from what we did last day? It looks pretty similar. The difference is that 3 right there. That is the b value. What impact is that going to have? Well, we just talked about it. It's going to impact the period. So let's just figure out right away what impact it's going to have. It's going to change the period of this cosine graph from 2 pi to 2 pi over 3. In other words, the period is only a third as big. It's smaller. It repeats more often. Okay, so now what we want to do is we want to figure out for which value of cosine, for which angle, do you get a cosine amount of root 2 over 2? Okay, two things. First of all, where's cosine positive? Cosine's positive here and cosine's positive here, right? First and fourth quadrant. So root 2 over 2, if you think back, that's when it's 45 degrees here, or of course if you had a 45-degree reference angle down here. But we're not interested in degrees, we're interested in radians. So 45 degrees is pi over 4. So we would say that x equals pi over 4. No, we wouldn't. We wouldn't say x equals pi over 4. We'd say 3x equals pi over 4. Right? We want some angle in here so that you take the cosine of it and you get root 2 over 2. The whole angle is pi over 4, but we only want 1/3 as much because you're going to multiply it by 3 before we take the cosine of it. Look that over. Hopefully that makes sense. Okay, so we have to solve this equation now. This is 3 times x. We have to divide by 3. You get pi over 12. Flip and multiply when you divide, right? Now let's take a look at the other angle. For this angle right here, how do we get that one? We take the whole circle, the whole way around, which is 2 pi, and we subtract the reference angle, which is pi over 4. That's not what x equals, that's what 3x equals. So 3x equals, let's put this over 1. You get, multiplied by 4, you get 8 pi, take away 1 pi, equals 7 pi over 4. And then divide by 3, you get 7 pi over 12. So these are 2 answers. 2 of all the answers, or is there more? Well, let's graph again. Love the graph, love the Desmos, let's use it again. So we have cos 3x equals root 2 over 2. Okay, first of all, let's put in y equals cos x, not 3x. And you can see it's that mother function graph. It goes through 0, 1, then it goes down and up, has a period of 2 pi. Now, when I put 3 in here, watch what happens. You should know what happens. It's a horizontal compression, isn't it? Boom, it gets squished. So if we go from 0 to 2 pi, you can see you now have a whole bunch of zeros or x-intercepts there. Whereas before, we only had 1, 2 x-intercepts. Now we have 1, 2, 3, 4, 5, 6. Hey, we have 3 times as many. Okay, so guess how many more answers we should have? 3 times as many answers. And the other side of the equation was root 2 over 2, right? And there's our root 2 over 2. So here's our answers. One answer should be at pi over 12. Another one should be at 7 pi over 12. Did we get those ones? Yes, pi over 12 and 7 pi over 12. But you see, that's not all the answers. We also have this answer, and this answer, and this answer, and this answer. This one's too big, isn't it? It's more than 2 pi. So we have 1, 2, 3, 4 more to go. Now, what's the relationship? Well, this point here, the next point, is 1 period away from the first point. 1 period. And then another period from that one is this point. This point is 1 period away from that point, whoops, and then another period away from that point. So we have to add a couple more periods to each of our answers. So let's go back and do that. We already saw that the period was 2 pi over 3. So what we do is we take this answer, and to get another one of the points, we add the period, 2 pi over 3. Okay, you got to get common denominators, so multiply the bottom by 4, multiply the top by 4 to get 8, plus 1 is 9 pi over 12, which is the same as 3 pi over 4. Okay, now we want to get another one. So we take 3 pi over 4, the answer we just got, and we add another 2 pi over 3. Oh gosh, common denominators, multiply top and bottom by 3, you get 9 pi. Multiply top and bottom by 4, you get 8 pi. So we get 17 pi over 12. If you're not sure and you thought, well, I don't know, maybe you can even get another one. Let's try 17 pi over 12 plus another 2 pi over 3. So multiply by 4, you get 8 here. You get 25 pi over 12. How do you know that's too big? Because 2 pi is equal to, it has to be smaller than 2 pi, right? And 2 pi is the same as 24 pi over 12. This is 25 over 12. So this is too big. We found 2 more answers here. That's when we went from here and we added 1 period and another period. You can see you're going to have 3 times as many. Because you're dividing by 3, you actually get 3 times as many because of that horizontal compression. Have we found all of them? No. Now we need to add that period onto this one. So we get x equals 7 pi over 12 plus the period, which is 2 pi over 3, equals, multiply by 4, that's 8, so you get 15 pi over 12, which is the same as 5 pi over 4. And x equals, take that answer, 5 pi over 4, and add the period again, which is 2 pi over 3. You get 15 pi over 12 plus 8 pi over 12 equals 23 pi over 12, just a tiny bit less than 2 periods, but it's still acceptable. So those are our final 2 answers. In other words, what we're doing for our general form is we're taking pi over 12 and we're adding the period 2 pi over 3 as many times as we want. And the other answer is this answer, 7 pi over 12. Plus the period, which is 2 pi over 3, and again n. So that's general form, and all the highlighted 1, 2, 3, 4, 5, 6, that is the conditional statement. Okay, another one. Tan 1/2 x equals 1. So again, you have a b value here. Remember, for the period of tan, it's pi over b. So in this case, it's pi over 1/2. And when you divide that, flip and multiply, you get the period is now 2 pi. So let's take a look at how that impacts things. Alright, we start off normally, we ask when's tan positive? Tan is positive in the first and third. For which angle do you get a tan value of 1? Oh, you get that when it's 45 degrees here and 45 degrees here. But we're not interested in degrees, we're interested in radians, so this is pi over 4. Do we say x equals pi over 4? No, 1/2 x equals pi over 4. So to solve that, we multiply both sides by 2. We get x equals 2 pi over 4, or x equals pi over 2. For the other angle, for this one, how do we do that? We take 180, or pi, and we add on the reference angle, which is pi over 4. Is that what x equals? No, that's what 1/2 x equals. So 1/2 x equals, this is 4 pi over 4 plus pi over 4 equals 5 pi over 4. If you multiply by 2, you get 10 pi over 4, which equals 5 pi over 2. What do you notice about that? It's too big. You reject that. It's too big. It's not within 2 pi, right? 2 pi is the same as 4 pi over 2. This is 5 pi over 2. It doesn't fall within this area right here. So it doesn't fall within the restriction there. So this is too big. We only end up with one answer right here. Pi over 2. That's our only answer. In terms of general, x equals pi over 2 plus the period is 2 pi and then the n. So 2 pi n. Okay, solve this equation right here. You can see you have cosine 2x's on both sides. You have 1 cosine 2x on this side, 5 on that side. So let's move this cosine 2x over and subtract. So we're subtracting cosine 2x. Let's move this 2 over and subtract. So we're subtracting minus 2. So we have negative 1, take away 2 is negative 3. And 5 cosine 2x, take away 1 cosine 2x equals 4 cosine 2x. Then we should divide both sides by 4. So we get cosine 2x equals negative 3 over 4. Okay, where does cosine negative? Cosine's negative here and here. When does cosine equal 3/4? I have no idea. Huh? What? This isn't a special angle. Alright, so you have to do an extra step here. You have to figure out the reference angle first of all. How would you figure that out? You would do inverse cos of 3/4. Forget about the negative for now. If you do that, plug it in your calculator, make sure it's on radians, you'll get 0.7227 radians. So either in this quadrant you're going to have that 0.7227, or in this quadrant you're going to have 0.7227. If it's in this quadrant, how do we get the angle, that angle right there? We take the whole amount, which is pi, and subtract 0.7227, the reference angle. Is that how much x equals? No, it's how much 2x equals. So 2x equals that. So take your calculator and go pi, take away 0.227, you'll get 2.4189. And then divide by 2, you get 1.209. So that's one answer. How do we get this one here? We take pi again, which is 180 degrees, and we add our reference angle 0.7227. Is that what x equals? No, it's how much 2x equals. Take your calculator, add those. You're going to get 3.8642. Divide by 2, x equals 1.932. Now, our period is 2 pi for cosine divided by the b value of 2. So our period is pi. So we would expect that you would get some more answers here. How many more? Twice as many because of the 2. How do we get them? Well, for one of them, we take this value, 1.209, and we add another pi, another period. And if you do that, you're going to get 4.351. Say you were confused, you didn't know when to stop. You added another pi. You'd get 7.492. How do I know that's wrong? Because it has to be between 0 and 2 pi. 2 pi is 2 times 3.14, which is the same as 6.28. That is a useful number to memorize. So that's too big. So that's it for that one. And the last one we get is we take this 1.932 and we'd add another pi. And if you do that, you'll get 5.074. So those are our 4 answers there. General form, x equals 1.209 plus the period's pi, so plus pi n, or x equals 1.932 plus pi n. That's our general form. Okay, last question. Solve this equation. Oh my word, I have no idea how to solve this. Can't factor it. You got tans and cos. This looks really hard. You know what we do? We give up and we use Desmos. We use our graphing calculator. There are some that you just have to use a graphing calculator. So we're going to graph two things. We're going to graph y equals tan x minus 3. We're going to graph y equals cosine x plus 2. And you're going to see where they cross each other. Y equals cosine x plus 2 looks like that. And we end up with this. If we want all the answers between 0 and 2 pi, we look for where they cross each other. There's one place they cross. Now, we're only interested in what x equals, right? So this x value is 1.38, and this one's 4.507, and that's too big. That's more than 6.28, more than 2 pi. So we have two answers, 4.507, 1.38. Let's go down and go back and write them down. We get x equals 1.38 and 4.507. General form, well, you can bet that we have this involved. But then, how much are we adding? What's the period? We got to figure out what the period is, right? Are we adding 1 pi, 2 pi? So let's take a look and see if we can figure out what the period is here. So we want to know what's the difference. This is where the graph is coming down and it crosses. This is where I'm talking about the orange one. It's coming down, it's going up. So that's not a period. It's coming down. Okay, here's a period from here to here. Oh my gosh, how do we figure out how much that is? Well, this is 7.664, and this is our 1.38. 7.664. Take away the 1.38, 4, 5, 8, 2, 6.28. Didn't we talk about that number? Yes, this is 2 pi. So the period is 2 pi and slap an n on it, 2 pi and slap an n on it. And we're done at last.